Assalamualaikum warahmatullahi wabarakatuh, and hi, we meet again, and today we will talk about voltage regulation in synchronous generator. Okay, let's start. What is voltage regulation? Okay, we will start by defining what is voltage regulation. Voltage regulation indicates how far the voltage at full load compared to the no load. Assume a synchronous generator, okay, when it's operating at no load, okay, it's giving a certain value of voltage, but then when you turn on the load, okay, normally the voltage will going a little bit lower, okay, sometimes a little bit higher, but normally it's go a little bit lower. If in ideal case it stays the same at full load condition, that's mean voltage regulation is 0. Okay, when you see voltage regulation 0, that's mean the voltage at full load is the same as voltage at no load. Okay, mathematically voltage regulation equals to, okay, no load voltage minus full load voltage divided by full load voltage, and then you times by 100%. Okay, so let's say if we got here a very simple example, full load is 400 volt, okay, no load is 440 volt. What is voltage regulation? Okay, this is very simple because all the two value has been given. That's mean 400 volt, 440 volt minus 400 volt divided by 400 volt. Okay, that's mean 40 over 400, so you get 10% voltage regulation. Okay, so this is very simple. Okay, now we go to our normal example that you will see. Okay, a 480 volt 50 Hz Y connected 6-pole synchronous generator has a per phase synchronous reactance of 1 ohm and per phase armature resistance of 0.5 ohm. Its full load armature current is 60 ampere at 0.8 lagging power factor. The field current has been adjusted so that the terminal voltage is 480 volt at no load. This last sentence is actually very familiar. Most of the question about synchronous generator have this. What does it means? It means that when we start the generator, we adjust it field current so that the terminal voltage, the output voltage, the one that we measure at the output of the generator, is 480 volt without any load. Then we leave it. Okay, so when you see this sentence, it means the internal generated voltage EA will be tuned to this to give this voltage, and then it will leave to be like that. In this case, is tell me, is this Y connected or is it delta connected? That's one of the first thing that you need to figure out when you answer question like this. You know that it's Y connected. Okay, it's best to draw. Actually, when you have something like this, it's best to draw. Okay, the question this question asks about the terminal voltage if it is loaded at rated current at 0.5 lagging power factor. We will see about that. And then it asks about voltage regulation. Remember, voltage regulation is V no load minus V full load. Okay, in this case we already know our V no load, it's 480 volt. But what is our V full load? That is what we are going to figure out. Now draw the circuit first. It's best to draw the circuit so that you know what you're doing. Okay, Okay, that's our reactance, armature resistance, synchronous reactance, armature resistance, and then synchronous reactance. Okay, and now we have our terminal voltage here. This is our terminal voltage, the one that we measure. This is the one at 480 volt at no load condition. Okay, no load condition, that means this current, the load current, is 0. Again, so at this condition, it's important to figure out what is the internal generated voltage, EA, at this condition. How do we get EA? The current is 0. That means there's no voltage drop across the impedance. This armature reactance, let me label this armature reactance and this synchronous reactance. There's no voltage drop there because I equals to 0. So how do we get EA? Okay, so the only way to get EA now is to realize how this machine is connected. So right now you need to realize that EA, okay, is equals to V phase, okay, and that V phase at no load, okay, no load condition, and this equals to VT at no load condition, okay, terminal voltage at no load condition, divided by square root 3. Okay, so we know now that our EA is 480 volt divided by square root 3. You will get around 277 volt. Okay, point something, but yeah, you can neglect that. Okay, now we have our EA, and this EA will be fixed. Okay, when we change our load, this EA will not change. It's good now that you draw the per phase circuit, okay, the simplified circuit. Okay, so what we have is we got our EA, okay, 277 volt, okay, then we got our RA, armature resistance, at 0.25 ohm. We got our RS, synchronous reactance, at 1 ohm. Okay, then you got your load. This is the load. Okay, and now the current. The current what we have now is 60 ampere at 0.8 lagging power factor. Okay, so now we have our per phase equivalent circuit. We can solve this problem. Okay, so how do we solve this? Okay, remember my previous video, we have talked about how to solve something like this. What you have now is actually you need to figure out what is the V phase here. Okay, if I draw another terminal, okay, this terminal, okay, let's use another color. If I put my voltmeter here, I will measure another voltage. That is our V phase. Okay, remember at the end we need to get the terminal voltage, not the phase voltage. Okay, so later you will need to multiply with square root 3. Okay, now we have our V phase there. Let's draw our phasor diagram. Okay, after you have that, you understand the circuit, you draw the simplified version equivalent circuit. Now number 3, you need to draw the equivalent circuit. All that we do is we want to get the full load voltage. Right now we don't know what's the full load voltage, so I'll draw my V phase. This is the component that we don't know. Put this component at 0 degree. Okay, then I draw my current. This current is at 0.8 lagging power factor. So how do we get the phase of the current? This is 0.8 lagging, so to get the theta, okay, is equals to at cos of 0.8. Okay, what do you get? Negative 3687. Okay, so that's the current, so it will be around that. Okay, that's more like 45. Okay, there you go. This is our current at 36.87 degree. Okay, and this is our I, 60 ampere. Okay, now when we have this, we need to multiply this current to be our voltage drop across the RA and across the SS. Okay, let me use blue. Okay, okay, it will go about the same angle. Okay, you know, it's very hard to draw the same angle using this tablet here. Okay, but I'll try. Okay, so we got the same angle there. That's 33.87. now this is IA RA. Okay, and then after we got that, let's change to another color, and then we got another one from that point at 90 degree. This will be IA XS. Okay, at 90 degree. So if you draw this together, okay, that and then here, okay, we will have our beat triangle now, and from that, ooh, it's very hard. Okay, now from the start of from the start of V phase till the end of IAXS, that will be our EA, which we already know, 277 volt. What we don't know is this one, V phase. Okay, these two we can calculate, IARA and IAXS. We can calculate that because we already know that RA is 0.25 ohm and XS is 1 ohm. Okay, so how do we get V phase? How do we get V phase? Okay, actually you can get V phase according to my other video. You can see that using Pythagoras theorem. When you got triangle like this, okay, you can use Pythagoras theorem, A square plus B square equals to C square, where our C is our hypotenuse EA. Okay, now I will zoom in so that we get our clearer picture. Okay, and now let's use this. All right. Okay, I'll try to draw as beautiful as I can, but it's not easy. Okay, so to get our, remember the big triangle that I told you. Okay, put into shape. Okay, so that this is our triangle. Oh, tak boleh. Okay, remember we talk about the triangle, the big triangle. This is our big triangle. Okay, so now we will decipher the information. First, this information from this point to that point. What is it? Yes, you are right. This one is IA RA cos theta. Okay. What's the number? IA is 60, RA is 0.25. When you times them together, IA RA becomes 15. And then cos theta is 0.8. So 15 times 0.8, you will get IARA cos theta 12. Yeah, so we got 12 volt here. All right, then we decipher this information. This is IA RA sin theta. Okay, IA RA sin theta is 9 volt. Okay, now we have that. Let's go to our XS. IASS. Okay, using trigonometry, you can calculate this whole line. Remember, our theta now is here. This is theta at 36.87 degree. So this is IASS cos or sine? Cos theta. Yeah. And what's the number? IASS cos theta is 48 volt. Okay. And we got another one here. This is IASS sin theta. And this is 36 volt. Okay, now, oh sorry, okay, now we have all this information. Can we get our new triangle? Okay, I will use the new triangle. Okay, oh, now it looks good. Okay, the new triangle. Okay, we already know EA is only up to here. EA is only up to here. Okay, and then we got our 12. Okay, we know we got our 12 volt here, and we have our 36 volt here. Okay, remember this is our V phase. Okay, and what about this line, this whole line? How do we get this? We know that 48 is from the top to the bottom, but then we need to minus this 9 volt. So this position is 48 volt minus 9 volt. Okay, so you got 39 volt there. Okay, and then we got our EA at 277 volt. Now when we have this information, can you get V phase? Of course you can. Okay, of course you can. You can refer to my video to get the right equation, okay, but I will go this step by step so that you know how easy this looks like in terms of numbers. So when we solving this 277, okay, let's use big screen over here. Okay, 277 volt square equals to V phase plus 12 plus 36 is 48, okay, square, then plus this side 39 square. So how do we get V phase? V phase will be equals to 277 square minus 39 square, then square root everything because of this sign, after that minus 48. Okay, when you solve that, you will get V phase at 226.37, 226.37 volt. Okay, then we got our V phase. After you got a V phase, okay, is this the answer? No, we need to get our V terminal. V terminal is V phase right now at full load condition. Okay, this is V phase at full load condition, 0.8 lagging power factor. Now we got our V terminal at 0.8 lagging power factor, full load current times set 3 equals to 392 volt. So that's our answer for the first part of the question, which is the load voltage. Okay, if you want to write down the full sentence, this will be V terminal at full load at 0.8 lagging power factor. That's 392 volt. Okay, so we got one answer here. Our next question is about VR. What's the VR? So VR equals to no load voltage 480 volt minus full load voltage 392 divided by full load voltage 392 volt, okay, times 100%. You will get 22.42%. Okay, I know this is a little bit long, okay, and I don't write the full equation. I go this step by step so that you know how easy when you put numbers into the equation. If you want to get the equation itself refer to the book. We got Chapman book, we got our notes. Okay, so what should we do now? Okay, after you understand this step-by-step concept of solving this equation, you should go to column. Okay, we already put question in column so that you can do this exercise on your own. Okay, remember, voltage regulation will change at different power factor. Okay, when you draw the phasor diagram, you will see the plus and minus signs will change. Okay, so just solve it as you understand it, and if you get every question right, that's mean you already understand the concept, you already have the capability to calculate. Okay, I'll stop here. I wish you all the best. So good luck. Assalamualaikum and hi. Bye.